Alright, today we're going to talk about solving multi-step equations. In the first video we looked at one-step equations and there was one operation that you saw. In this case, when we look at multi-step equations, there are two or more operations or steps needed to find your missing variable. Most likely it's going to be a combination of adding and multiplying, or adding and dividing, or subtracting and multiplying. But there's at least two operations there. Okay, and the important thing you need to do is multiply or divide last. And there's one case where that doesn't happen, I'll show you, but think about multiplying or dividing last when you solve these multi-step equations. So we're going to look at a few to solve. Alright, our first equation is, we're going to solve 1/3 x plus 6 equals -8. So there's two operations I see. I see the multiplication here with the 1/3 and the x. And I also see adding 6. So with my advice, I'm going to multiply or divide last. So I look at my operation, and I know it's addition, so I have to subtract 6 from both sides first. So that's what I do. I go ahead and I subtract 6, and I'm left with 1/3 x equals -14. Okay, so now I have this operation of multiplication. To undo multiplication, you can divide by 1/3. Dividing by 1/3 is the same as multiplying by 3, so I chose to multiply each side by 3, which will eliminate the denominator here and leave me with just x, and -14 times 3 is -42. So my solution is x equals -42. And that's just our first basic two-step equation, multi-step, two operations. Okay? Alright, so in the next example we're going to solve 7x minus 3x minus 8 equals 24. So the first thing I'm going to rewrite my equation down here, and then I notice I have two terms with x's in it. So step number one is to combine like terms. So I'm going to add the 7x, and I'm going to take the 7x and I'm going to subtract off 3x's, which gives me 4x's. Everything else comes down. So my new equation is 4x minus 8 equals 24. Okay, so this is really a two-step equation because you have two operations, multiplication and you have subtraction. So again, I'm going to look at multiplication and division last. So I have subtracting 8. Well, to undo subtraction, I add 8 to each side, and that's exactly what I do. These cancel. You're left with 4x equals 32. Now, mental math would say 4 times what number is 32? It's 8. Algebraically, we would say, well, how do we undo multiplying 4? You divide each side by 4. Dividing each side by 4 leaves me with x equals 8, and I have solved that equation. To check if my answer is correct, I could go back up and plug 8 in for each x, or I could start here on this two-step equation. 4 times 8 is 32. 32 minus 8 is 24, so my answer would be correct. Okay, so here's another multi-step equation that is actually going to use one of our properties, the distributive property. We're going to solve 5x plus 3 times the quantity x plus 4 equals 28. So there's a lot going on. First step is always distribute. Get rid of that parentheses. So the 3 is going to be distributed to the x and to the 4, which gives me 3x plus 12 here in red. Every other term is going to come along for the ride. So we have 5x plus 3x plus 12 equals 28. And like in the last example, we're going to combine like terms now. I have 5 x's and I have 3 more x's. That gives me 8 x's. So I combine like terms. The 12 comes down, the 28 comes down. And now I again have a two-step equation where I'm going to undo the addition of 12 by subtracting 12 from both sides. So I subtract 12 from both sides. I have 8x equals 16. Mental math would tell you that 8 times 2 is 16. So your answer is 2. But also, if you wanted to do it algebraically, undoing multiplication, you divide each side by 8, and you get x equals 2. In our last two examples here, this example is still similar to the previous one, but I wanted to give you an example. We have an operation of subtraction. Okay, so be careful here with that negative sign. If I change this to a negative, adding -3, we want to watch out. But you really got to make sure you look out for the subtraction. So we're going to distribute again first. So subtracting 3, pretending this is a negative number, we're going to distribute -3 to both terms, and you get -3x, and a negative and a negative make +6. Okay? Every other term comes along for the ride. The 4x comes down, the 21 comes down. And now again, look, you have like terms, 4x minus 3x. So we're going to combine those like terms, and it actually gives us x here. The 6 comes down, the 21 comes down. I haven't done anything with those. Now, more mental math. What number plus 6 is 21? The answer is 15, and you can leave it like that, or algebraically you subtract 6 from both sides. But if you can do mental math, go ahead and do that. That's fine. You don't have to show all your steps here. So that's how we distribute with the negative. Okay, just be very careful when you see that subtraction. It's going to change the sign here, and when you have that -2, so -3 times -2 is 6. So just be aware of that. Last example goes back to the first slide when I say always multiply or divide last. Now we're going to solve 66 equals -6/5 times this quantity x plus 3. Now in this case I'm not going to distribute as I did in the other two examples, because the number out front is a fraction and it's not going to simplify very easy. Okay, it's going to give us a decimal. So what I can do is multiply each side by the reciprocal of -6/5, which is -5/6, and I've done that here. Multiply each side by the reciprocal. Now these two numbers will become 1, so that quantity x plus 3 comes down, and -5/6 of 66 is -55. Okay, 6 goes into itself once, 6 goes into 66 11 times, 11 times -5 is -55. That's where that comes in. Again, x plus 3 equals -55, subtract 3 from both sides, and you're left with x equals -58. So these are multi-step equations. Just to review, you have more than one operation here. It's got to be at least 2. Most of the time you're going to add or subtract last, except for maybe if you distribute here and there's no other term. Like we did in this last example, we got rid of the fraction first because it's not beneficial to distribute too many fractions. All right, we'll see you for the next video. Thanks.